Hello, AP Environmental Science class. We're moving on now to Chapter 16, Environmental Hazards and Human Health. This is probably the chapter, if we're going to talk about the 2020-2021 year, this is going to be the chapter for us because what we're going to talk about are hazards to human health in this chapter. And obviously, one of the main hazards to human health are viruses. And of course, what are we dealing with? The COVID-19 pandemic that has been affecting us for the past year or so. So a lot of the stuff we're going to talk about in this chapter has been all over the news the past year or so. So in many ways, you guys are going to be situated in a better place to kind of understand and appreciate this chapter than maybe previous colleagues of yours will have had. So we'll get right to it now. All right. Again, there are about 59 slides here, so I should be able to do this in 2 lectures. All right. So there should only be 2 parts. So first off, we have a core case study where we talk about mercury's toxic effects. All mercury compounds are toxic. 1/3 in the atmosphere comes from natural sources. Unfortunately, human activities provide the rest of the mercury compounds that are found in the atmosphere. 2 main human exposures to mercury: fish contaminated with mercury. You may have heard about this. For instance, some fish you don't want to eat a lot of because they could have some mercury contamination to it. We'll talk about that biological, that biomagnification that we talk about as you go through the trophic levels. And by the time you get to fish, which are kind of a little higher up on the food chain, the magnification of that mercury becomes a little bit greater. And as a result, could be harmful to our health. And inhalation of vaporized mercury are also another main cause of human exposure. Mercury can cause birth defects and brain damage. If you remember in the olden days, maybe you guys don't remember this, but thermometers used to be filled with mercury. They are no longer filled with mercury because too many students were breaking these thermometers and getting some effects from the toxicity of the mercury if they touched it when it fell on the ground, etc. So now thermometers are not filled with mercury anymore because of these toxic effects. So again, this is just a notice. Fish from these waters contain mercury and may be harmful to eat, especially for women and children. Again, talking about that biomagnification as that mercury goes through the food level. By the time it gets to fish, it's at a level that it could harm us as a human species when we eat it. So again, something to think about, this mercury. So what major health hazards do we face? Well, the major types of hazards that threaten human health: biological hazards, chemical hazards, natural hazards, something called cultural hazards, and lifestyle choices can end up being a hazard as well that could threaten your health. All right, and what we're going to do here in this chapter is we're going to talk about all of these and kind of dive into them in more detail. So first, we face many types of hazard. Let's go over some terms so that you kind of understand what we're talking about when we talk about some of these terms. So what is risk? Risk is the probability of suffering harm from a hazard, and it's expressed as a ratio or a percentage. So obviously, if there's a 90% risk, you'll have a greater chance of suffering harm from a hazard than if that hazard has only a 50% risk. Okay, so it's as simple as that. All right, risk expressed as a ratio or percentage. And again, the probability of suffering harm from some sort of hazard. Risk assessment is something where people use statistical methods to estimate harm. Many insurance companies have people who actually just do this as a living, as a risk assessment. They're part of the insurance companies, and they use stats to kind of estimate harm for insurance, and then that kind of allows your rate to fluctuate, all right, depending. Risk management is deciding whether and how to reduce a particular risk. So basically what the steps are, we look at a risk, all right, then we assess the risk, okay, and then depending on what the assessment comes out as, we then use that information to manage the risk in a way, and that would be deciding whether or how we can reduce that particular risk. So what do we do in a risk assessment? First, we identify the hazard. What is it? Then again, we look at that probability of a risk. Again, kind of just what I talked about. How likely is that event or that risk going to happen? And then we take a look at the consequences. What is the likely damage? And then again, we can use all of that to kind of determine how we're going to proceed with that risk or with that hazard. Then we go to the management part and we compare the risk analysis. How does it compare with other risks? Again, risk reduction. How much of it should be reduced? We then come up with some sort of strategy, a risk reduction strategy. How will the risk be reduced? How are we going to do it? And then obviously we need to know if the money is going to be involved. So a financial commitment will come into that risk management, how much money should be spent to reduce the risk. So again, this is all part of this. And again, there are companies that have people who do this. So if you're into this, if you're into statistics and kind of going over this risk and risk management, maybe this is something that you can get into, environmental risk management. Definitely, again, many companies have these people working in their company assessing risk and then managing that risk. Biological hazards, all right, we spoke about that. These are some of the types of hazards we're going to face. So what is a biological hazard? Well, basically a pathogen, an organism that causes disease in other organisms. Chemical hazards are harmful chemicals in the air, water, soil, and food that affect us, like the mercury we looked at in the core case study. That would be a chemical hazard. Natural hazards include fire, earthquakes, volcanic eruptions, floods, tornadoes, hurricanes. I would even say winter outbreaks. We're listening in the news about Texas having an outbreak of winter weather down there. They weren't able to handle it, and so you had people losing their lives because of that. So I would even include winter weather outbreaks, cold, snow, things like that as natural hazards. So again, biological, pathogens, some sort of organism or a virus, right? Like our COVID-19. Chemical, all right, natural. Then we have cultural hazards. So what are that? That's going to be unsafe working conditions, maybe criminal assault, maybe poverty. Okay, poverty is unfortunately a cultural hazard. And then of course, lifestyle choices you can bring hazards upon yourself by the choices you make in your life. Smoking, for instance, making poor food choices, having unsafe sex, things like that. Okay, are lifestyle choices that can add hazards to your life there. All right. So once again, we're going to kind of talk about all of these in a bit more detail as we go forward. So first, we're going to talk about biological hazards. And then actually, that'll be the end of this lecture, and then we'll talk about the rest, starting with chemical hazards with part 2. All right, so how do biological hazards threaten human health? The most serious biological hazards we face are infectious diseases. Examples: the flu, acquired immune deficiency syndrome, otherwise known as AIDS, tuberculosis, diarrhea diseases, malaria, and of course, COVID-19, all right? Obviously, that's the main one in the news right now, okay? So these are examples of biological hazards, okay? And again, infectious diseases, pathogens that invade the body and multiply. Viruses, bacteria, and parasites are considered infectious diseases. And obviously, what is COVID-19? It is a virus, okay? So it fits into that infectious disease category. It's also a transmissible disease, contagious or communicable disease between people, infectious disease transmitted between people, okay? So examples: the common cold, tuberculosis, gonorrhea, or again, COVID-19. We could be adding to all these slides here, as obviously it is a very transmissible disease, and that's why we're having such issues with it around the world. What is a non-transmissible disease? Well, this is a disease not caused by living organisms. So examples would be cardiovascular disease, heart problems. Most cancers, okay, are not caused by living organisms. What are cancers? They're just your own cells that end up mutating and end up causing harm to other cells. So it's kind of yourself harming yourself in a way. So it's not another living organism moving in. Asthma, diabetes, okay? These are all examples of non-transmissible diseases. You cannot transmit diabetes from one person to another. You cannot transmit cancer from one person to another. If I have lung cancer, I'm not giving lung cancer to you by breathing on you. However, if I have COVID-19, I'm going to give it to you by breathing on you. Okay, that's obviously why we're all wearing masks, okay? So that's the difference between transmissible and non-transmissible diseases. What is an epidemic? Again, a year or two ago, you may have never heard this term. Now, this term is pretty much on everyone's mind. Epidemic is a large-scale outbreak of an infectious disease. And what is a pandemic? A global epidemic. So an epidemic could be localized, but if it ends up happening across the entire globe, then we call it a pandemic. And obviously, we've been hearing that word over and over again for the past year or so. So again, you guys all know what a pandemic is. All right, so some diseases can spread from person to person. Again, we're talking about these are your transmissible diseases. And again, these are the deaths per year. So lower respiratory infections, bacteria and viruses, all right? 3.1 million deaths per year. I would put COVID-19 in that. I would put the flu, okay, in that, lower respiratory infections, okay? So obviously, most people are dying from those over the year, per year if you average it out. All right, tuberculosis comes in number 2, HIV and AIDS number 3, hepatitis 4, diarrhea diseases caused by either bacteria or virus. Then you have malaria, which is actually a protozoa, and then you have the measles there at the bottom, which is a virus. So again, obviously, it's those lower respiratory infections that get most of us. That's your flu. And that's as well your COVID-19. I would consider that a lower respiratory infection. Obviously, COVID-19 caused by a virus, not a bacteria, but there are bacteria out there that can cause lower respiratory infections as well. Infectious disease was the leading cause of death in the world in 1900. However, the incidence of infectious disease has dropped significantly since then. That's because of all our medicine, access to cleaner water, access to more sanitary conditions, meaning, toilets, things like that, that in the 1900s, not everyone had. Now, as we're in the 21st century, still not everyone has, but many more people have access to fresh water and to sanitary devices and to better medical health. And so obviously the incidence of these infectious diseases has dropped, but still a problem, especially in the less developed countries. All right, and that's again something that we need to kind of fix as we go through this 21st century. Many disease-carrying bacteria have developed genetic immunity to widely used antibiotics. So again, another issue. We talked about it with pest management. Remember a couple of units ago how the pests multiply so rapidly that they actually end up getting immune to the antibiotics. Well, that actually happens in disease-carrying bacteria as well. They replicate very quickly, and so what happens is mutations occur that allow some of the bacteria to be resistant to the to the antibiotics, and then over time, not that long of a time, as the population of bacteria continues, they end up getting immune to that antibiotic, and then we have to come up with another form of antibiotic. Climate change also allows disease vectors to increase their range. Okay, so when we change our climate, we're changing where certain diseases may be able to multiply faster than in other areas, and that obviously messes up the ecosystem, because you may have diseases showing up in an area that they've never been before that disease because the climate wasn't suitable for it. Well, now the climate is, and so now you have this disease showing up. The population doesn't have any immunity to that disease because they've never had it before, and now you have that infectious disease running wild in that population. All right, and again, could be talking about people, we could be talking about animals, et cetera, et cetera. This obviously chapter is about human health, so we're talking more about human beings here, but just realize it could affect other areas as well. All right, so another case study here, the global threat from tuberculosis, otherwise known as TB, is a highly contagious bacterial infection of the lungs. It's been spreading since the 1990s. So why is it on the rise? Well, we have a lack of screening and control programs, especially in those underdeveloped countries. Genetic resistance to a majority of effective antibiotics. We came up in the past, in the 20th century, antibiotics to treat tuberculosis, but now, as we're heading into or through the 21st century, well, a lot of the bacteria that creates tuberculosis has become immune or at least resistant to a lot of the antibiotics that we have have created. And this means we have to go out and try to create more antibiotics. Person-to-person contact has increased, okay? In many places, especially in underdeveloped countries, people are moving out of the rural areas and into the cities. Many of them are living in shanty towns, okay, or close together, especially in these underdeveloped countries where they don't have a lot of sanitation, where they don't have a lot of cleanliness, I guess you can say. And so these people now living closer to each other allows this infectious disease that is very contagious to obviously spread through the population. And then, of course, population growth in general, air travel and urbanization, again, kind of just what I talked about, bringing people closer together. And you see this with COVID-19, right? Where are the biggest COVID-19 outbreaks? In the cities, right? Rural areas haven't really been affected so much by this COVID-19, or at least as much as, let's say, New York City or Los Angeles, okay? Things like that, Chicago, okay? Inner cities where people live closer together, obviously the threat from any type of health hazard will increase, all right? That risk is going to increase because of the close person-to-person contact. Here's just a picture of a tuberculosis in the lungs. Anywhere you see is red is areas where tuberculosis bacteria has destroyed lung tissue. And again, COVID-19, we see a lot of lungs kind of looking like this as well. Okay, so just something to think about. So some world agencies that kind of help us when we talk about human health. The United Nations promotes dialogue between countries with the goal of world peace. They also deal with international health matters. Obviously, you've heard of the World Health Organization. Okay, we are back in the World Health Organization. The previous administration had kind of moved us away from it. But what does the WHO do? The improvement of human health by monitoring and assessing health threats throughout the world. And the World Bank actually provides technical and financial assistance to developing countries when it comes to their risk assessment and helping them to alleviate some of the health concerns in their countries. The World Bank might step in and give them some assistance to maybe install running water in people's homes or flush toilets in people's homes to be able to live more sanitary and to then decrease that risk of getting some kind of health hazard. Viral diseases and parasites are also killers, all right? Influenza or the flu virus kills the most worldwide every year. And obviously, COVID-19 fits right in with that as well, okay? It is a virus, okay, similar to the flu. We also have human immunodeficiency virus, HIV, which causes AIDS. Affects about 2 million people per year. We have yet to come up with a vaccine for HIV. We came up with a vaccine for COVID-19, which is interesting, but that's because COVID-19 is similar to the flu, and so we kind of knew what to do here. HIV, completely different, and so we've been unable to come up with a vaccine. There are therapeutics now that help people with HIV and AIDS actually live long lives, but we have yet to come up with a vaccine. Hepatitis B, viral, HPV, another virus, Ebola, Luckily, we don't deal with that much here. West Nile virus, though, and the Zika virus, we actually do have here. Every now and then you'll hear, especially about the West Nile virus coming out of mosquitoes in this area, and we do get some outbreaks of that every summer and in the fall. And the Zika virus was around a couple of years ago. It luckily has waned. Viruses that move from animals to humans, that's the COVID-19 virus, all right? This is a new field of ecological medicine. Unfortunately, with animals and humans living more closely together now, I expect that we're going to see more of this in the future. So again, maybe another area of employment for you as you get out of here and go into the real world per se. Maybe you're going to get into this field where studies these viruses that actually jump from animals to humans. And again, that's what we're dealing with right now with the COVID-19 virus. Good hygiene can reduce the chances of infection. And again, it's so funny how this year, this stuff has all become second nature to all of us, right? Wash your hands. All right, how many times have you heard that? It's so simple, but it works. Do not share razors or towels. Cover cuts and scrapes until healed. Avoid contact with people with viral diseases, right? This is all about the quarantining we're going to dealing with, and wearing masks, for instance. Do not touch your eyes, nose, and your mouth, right? So again, a year or two ago, some of the stuff might not have been as mainstream as it is now. Now we all know that this is what helps us reduce the chance of infection. All right, it's reducing your chance of getting COVID. It also reduces your chance to get other infections. How many people have had the flu this year? Right? It's interesting. Part of me wants to wear a mask every winter for the rest of my life. I'm not going to, but part of me wants to, because I haven't been sick this year at all. Right? I have nothing. And I suspect many of you too have not been sick at all this year because you're wearing a mask, washing your hands, you're avoiding contact with people with viral diseases. That's your social distancing, right? And you're not touching your eyes, your nose, and your mouth. It's simple. All right, it's simple and it works. All right, core case study again, talking about the global HIV/AIDS epidemic. All right, AIDS caused by HIV. It leaves the body vulnerable to infections, and currently it's the leading cause of deaths of people ages 15 to 49 worldwide. So that kind of middle-aged people, I guess teenagers to middle-aged. The leading cause of death right now is AIDS, and the biggest issue is obviously continues to be in our underdeveloped countries. Again, no vaccine to prevent or cure AIDS. Again, we do have some therapeutics, costly drugs that can slow the viral progress. Those have been developed over the past 35, 40 years or so, since the AIDS epidemic kind of popped up in the late 70s, early 1980s. But again, we still don't have a cure for it. This is an interesting population pyramid, okay? This is from Botswana, which is a country for us in Africa. And what you're noticing, okay, is that this country, if without AIDS, you notice the people without AIDS have a perfect pyramid, right? A lot of people very young, right? And then gradually as they get older, the pyramid begins to get smaller as people die off. However, look at it with AIDS. You have a large amount of people in your 20s, right? Basically 15 to 30. And then look what happens by 45. That population drops by middle age, okay? It gets completely destroyed because you're losing those people from ages 15 to 30 are dying with AIDS, and they're not making it into their 40s and 50s, and so you have a population pyramid that is completely out of whack. All right, so something to think about here, and again, understand how to read these pyramids. They're very important. We did human population a couple of units ago, but again, we can look at these and use them to analyze and determine what's going on in countries, depending on, again, different variables. In this case, we're looking AIDS without AIDS, and you can see how devastating it is with AIDS, how you lose all your young people very early on, and therefore by the time you get to your 40-year-olds, there's no 40-year-olds, there's no middle-aged people left in the country. All right, so that is unfortunately hard to look at. If you understand how to read this pyramid, this is a very hard pyramid to look at, because what it's telling us is that with AIDS, you're losing people 15 to 30, and they're not even making it to 40 years old. Malaria is another big issue, a deadly parasite around the world. Okay, so there's a case study concerning malaria as well. Malaria is caused by a parasite carried by certain mosquitoes. Usually you get it in tropical and subtropical regions, and it can spread. Uninfected mosquitoes bite an infected person, later bites an uninfected person, and spreads that virus. All right, so mosquito bites you, you have malaria. Now that mosquito has malaria in it, it goes and bites another uninfected person. That person gets infected, and this goes on. And unfortunately, you have a big area. And climate change expects the spread of malaria to increase when you get global warming, right? So he's talked about this, how global warming can change the disease vectors and where they're going to be. For instance, here in Ardsley, we don't really talk about malaria here in Ardsley, right? But if the world keeps on warming and Ardsley ends up becoming a subtropical area, not going to happen in our lifetime, but let's say 100, 200 years from now, well, obviously then malaria could end up being an issue here in Ardsley. So now you have all these people in Ardsley who have never had malaria before. Now all of a sudden malaria shows up, and it's could have devastating effects. All right. So again, just some issues when we think about climate change. We just don't think about pollution in the atmosphere or rising waters, surface levels. Right. Climate change changes a lot and also can affect the spread of deadly diseases. All right. So again, something you don't think about when you think about climate change. Oh, it spreads deadly diseases. It does, or it can. All right. So, and we're going to do a whole chapter on climate change. It's actually the last chapter we're going to discuss in April, and we'll talk more about this stuff then. Malaria incidences are increasing since 1970. Drug relist. So the Plasmodium parasites are actually now again more drug resistant. Malaria showed up in the previous century, the 20th century. We came up with drugs to kind of combat it, right? And then what happened? The bacteria, the parasites, right? They're just like those pests. In the pest management, they're getting immune or genetically resistant to the insecticides or to any type of drugs that we have to kind of quell the outbreak. And so now we're actually seeing these incidents increasing. No effective vaccine is available for malaria. Insecticide-treated bed nets and window screens have saved 6.2 million lives between 2000 and 2014. So what do we mean by that? Well, here we go. So you'll notice this is an insecticide-treated mosquito net that this baby is sleeping under. All right. So it is treated with insecticides that then the mosquitoes don't want to go near it. And so this baby will not get bitten by a mosquito while he or she is sleeping. And obviously this has helped save many million lives over the past 20 or so years. Okay. So again, just more ideas, more of this environmental ideas. You know, think about the person who came up with this idea. Think how much money this person has now made. Again, it's not all about money, obviously. It's about saving lives. But obviously, for those of you 17, 18-year-olds in high school, I know a lot of you are thinking about how successful you're going to be when you grow up. Well, think about it. Not only did whoever invented this not only saved millions of lives, but I'm sure is also living in a very big house somewhere, right? So very successful as well. So kind of a win-win, saving lives and making yourself money. I love it. All right. So hopefully some of you guys can come up with some things like this and help save lives down the road. So how can we reduce the incidence of infectious diseases? The percentages of worldwide deaths from infectious disease dropped from 35% to 16% from 1970 to 2015. So this is a success story. All right. Again, we talk a lot about negatives in this class, a lot of negative things going on. But I think I talked to you about this before. I like to point out where the success stories are. And here is a success story. All right. That's a significant drop. And that's because more children are being getting these immunizations. Okay. Average annual deaths from infectious diseases in children under 5 reduced from 12 million to 4.9 million between 1990 and 2015. Again, another success story. Great job. All right. And again, more children getting those immunizations. And again, just living in cleaner environments, just understanding to wash your hands, understanding to avoid contact with people who have a disease. All these things are leading to at least the deaths and the worldwide deaths from infectious diseases to drop significantly in the past 30 to 50 years. So again, good job, but we still have much more work to do. So some solutions for you. Again, infectious diseases, increase research on tropical diseases and vaccines, reduce poverty and malnutrition, right? Poverty and malnutrition is that cultural hazard that we talk about. Malnutrition, all right, when you don't have enough nutrition, your body is not going to be able to fight off these diseases. And so it's even, your body's going to be almost like, come and get me. your body is saying, okay? So if we can, especially in children, all right, if we can make sure that they're nourished properly, then the body's own immune system will be able to deal with a lot of these infectious diseases. Again, improve that drinking water quality. You have no idea what clean water does compared to dirty water. It's like night and day when it comes to diseases. That's why in the last century, from 1900 on, we went from a lot of people didn't have access to clean water to a lot of people now having access to clean water. It really helps. And so we need to get into these underdeveloped countries that don't have access to clean water, and we have to get them access to clean water. It's very important. Reduce unnecessary use of antibiotics. This is key. I hate to say it, and again, this is my opinion. But in my house, we don't rush out if we have a cold. Again, this year, because we're wearing masks, not many colds. But when my children have colds or I get a cold in the past, we don't rush out and use antibiotics right away. Because what happens is if you always using antibiotics, all right, these diseases then, again, get genetically resistant to the antibiotics. So you only want to use it when you really need to use it, when maybe you have someone who is really, really sick, okay? But if you don't need it, let your own body fight off a disease. Very similar to the integrated pest management. I hate to bring it back to that, but almost let Mother Nature deal with the disease and not artificial means. To me, antibiotics are artificial means. Doesn't mean we don't use antibiotics. We do, but reduce the unnecessary use of the antibiotics. Sharply reduce the use of antibiotics on livestock. Again, same thing. These bacteria become genetically resistant. Immunize children against major viral diseases. Get those immunizations, okay? I know many of us teachers are getting the COVID vaccine. I'm sure many of you guys, once it's available to the young adult community, will get it as well. Get it. Okay. Provide oral rehydration for diarrhea victims. Diarrhea is a huge issue. You don't think about it much here in Ardsley, but in underdeveloped nations, it is a huge problem because you get dehydrated quickly, and then that causes everything else to stop working in your body. Okay. So we need that oral rehydration, some way to get these folks rehydrated when they do have bad cases of diarrhea. And conduct a global campaign to reduce HIV and AIDS, which we have been doing, but we obviously need to continue to do. Okay, so I'm going to end part one there. Part two will be a little more slides in part two, but I think this is a nice stopping point. When we come back for part two, we'll start talking about chemical hazards that threaten human health. So I will see you then.